In this problem, we have a disk that is a rigid body that's pinned at this point, so it's undergoing rotation about a fixed axis, the axis being perpendicular to this plane, to this screen, passing through this point. And there's a cord that's wrapped around this rigid body, this disk. The cord has a linear acceleration of 10t meter per second squared, so it's a function of time. And we need to determine the angular displacement theta, angular velocity omega, and angular acceleration alpha of the disk when t equals to 3 seconds, the disk starts from rest. So because the cord is wrapped around this disk, therefore the cord's linear acceleration is the same as the tangential acceleration of point P on the disk. So this point P right here will have the tangential acceleration at, that is the same as a, which is 10t. So because the tangential acceleration equals to alpha r, alpha being the angular acceleration, and r is 0.5, so this equals to alpha times 0.5. From here, you can solve for the angular acceleration alpha of the disk to be 10t divided by 0.5, that is 20t in the unit of radian per second squared. Therefore, at t equals to 3 seconds, we can evaluate alpha to be 20 times 3, and that is 60 radian per second squared. So that answers the first part of the problem. Is actually the third part, this one right here. So we got the angular acceleration. So remember, we do have the three basic kinematic equations between theta, omega, alpha as well. Therefore, alpha equals to d omega dt, which means that we can find omega by integrate alpha with respect to dt. In this case, we integrate from 0 to t equals to 3 seconds. Alpha is 20t function of time, dt, and this equals to 20 over 2 times t squared, evaluated from 0 to 3. So from here, we can evaluate omega to be 90 in the unit of radian per second. And that is the second half of this problem right here. And then because omega also equals to d theta dt, and omega is not 90 all the time. Omega is 90 radian per second at t equals to 3 seconds. Omega is actually also a function of time, that is 10t squared. Therefore, from here, we can find theta to be the integration of omega dt. So if we integrate this from 0 to t, we will have the general equation for theta, general function of time for theta, and that is 10 over 3t to the third power. So that is the theta as a function of time. But here, because we are evaluating theta at t equals to 3 seconds, so we evaluate it from 0 to 3, and that equals to 90 in the unit of radian. So now we have answered all three parts of this problem.